graders, and welcome to lesson 106 on solving two-step equations. So these problems are really fun because they set the foundation for solving multi-step equations, which have more than two steps. So eventually you're going to have problems that have all sorts of exponents and square roots and parentheses in them. And the way that you solve them is you want to get x by itself. And the way that we do that is we work backwards from PEMDAS. So what usually you would do first, we're going to do last. So usually you do parentheses and exponents first. It means that we're going to undo starting on this side, and we're going to undo it working this way, backwards. So the first or the last part of PEMDAS is addition and subtraction, which means that that's the first thing we need to undo. After we've undone the addition and subtraction, we can undo the multiplication and division. And then finally, eventually, you would undo what's in parentheses and exponents. So what you need to know is that the first step is to find your variable. You could even write that in here. Find variable. You want to locate it in your problem. Then you want to see what's happening to it. On that side of the equation, is there any addition or subtraction? If there is, we want to undo that first. What you do to one side, you got to do to the other side. Then we're going to undo the multiplication and division following this same step right here. And finally, we can check our work. So I have an equation shown here. I have 3x, and we showed each x with a popsicle stick, plus 2 equals -7. In order to get x by itself, what did I have to undo first? Right, the addition or subtraction. And I did that by first getting rid of the individual tiles. So if I have +2 and I want to cancel them out, I'm going to add a -2. And whatever I do to this side, I need to do the same thing to this side. So I added a -2 here as well. So now I have all my tiles on one side, and I still, though, have 3x, and I only want to know what 1x is. So I'm going to break these tiles into equal groups. So I have 1, 2, 3 groups. So over here, I need 1, 2, 3 groups. So I'm going to divide all these tiles into 3 equal groups. And now that I've divided them, I'm going to take away all but one group. So I took away 2 whole groups here, which means I'm going to take away 2 whole groups there. And now that I have x all by itself, I know that x equals -3. Let's look at one more. All right, here's our second equation. Try to write down what you think it is. Did you write 2x -4 equals -2? If you didn't, then go ahead and correct that now. So I have 2x -4 or plus -4 equals -2. I want to get x by itself. What am I going to undo first? Good, the addition and subtraction. And I do that by my tiles. So right now I have -4, and to cancel those out, I need to add +4. 1, 2, 3, 4. Now that they're all doubled, I can take them away. And whatever I did to that side, I need to do to the other side. So I'm going to add 1, 2, 3, 4, +4. So now I'm not done though, because I have 2 different colors over here. And remember that when I have one of each color, they're going to cancel each other out. A -1 and a +1 cancel each other out. So I showed that in the beginning of the year by lining them up this way. And this is the same thing if we're finding the sum of 2 different numbers with different signs. Find the difference. So 4 minus 2 of their absolute values says that there's going to be 2 left over, and they'll keep the sign of the bigger number. So those cancel out, and we have +2. Now I need to break these into how many groups? 1, 2 equal groups. Well, that was easy enough. I only want one group left, so I'm going to take away this group and take away this group. And so I have x equals +1. All right, now let's go on to today's lesson, which is looking at them written out. Okay, so let's jump into the examples. Example A says 3n minus 1 equals 20. So the first step is to find my variable. Where's my variable? Good, it's right here. So n is being multiplied by 3, and then 1 is being subtracted from it. So I'm going to undo the subtraction with addition. Plus 1. And whatever I do to that side of the equal sign, I have to do to this side of the equal sign. Plus 1. Then I'll rewrite it right underneath with what is left. Yes, you have to do these steps. Now, I've undone the subtraction, and now I'm going to undo the multiplication or division. So what's happening to n now? It's being multiplied by 3. I undo that by dividing by 3. What I do to that side, I need to do to this side. 21 divided by 3 is 7. So n equals 7. How can I check my work? Well, I would plug it right back in. So if I plugged a 7 in here, I would do 3 times 7 is 21, minus 1 is 20. It works. I did the problem right. Let's try example B. So in this one, we have our variable is still n, and this time though we're adding 4 to it. So in order to undo that, I'm going to subtract 4. What I do to that side, I need to do to this side. So now I have 3n equals 12. 3 is being multiplied. I undo that with division. I undo that, and I get n equals 4. Now what would happen if here I had some division is I would undo it with multiplication. And if I multiplied on this side, I'd have to multiply on the other side. Only 2 questions left. Oh, we didn't check our work. If I plug a 4 back in for n here, 3 times 4 is 12, and 12 plus 4 is 16. It works. All right, C. So what's happening to W? First, we got to undo the subtraction. I'm going to add on both sides. 4W equals 36. Divide by 4. Divide by 4. W equals 9. All right, try D on your own. Bring it to class. Go ahead and get to work.